Hi, I wanted to give you some kind of ideas for the project. Okay, so here's what you're going to end up doing. Okay, first thing I want to show you is this file right here. This is the input file that you're supposed to start with. Okay, and this is like a spreadsheet. Okay, so it's downloaded from a repository of information about exoplanets, and what it has is a row for each exoplanet discovered as of pretty much the end of the one of the exoplanet hunting projects from NASA, and what it features is for each candidate planet, it actually has some information. You know, it says things like what star it's orbiting, what the name of the exoplanet is, some of the orbital parameters of the planet, semi-major axis, for example, stuff of that nature. Okay, it's honestly not real important for building the application that you're doing, right? Although of course it's very important to the folks who care about this data. Now, a few things that I want to say. Number one, there is a lot of data here. Okay, there's not that many rows. There's only about 4,000 rows, but there's a lot of columns for each one of them. And you're going to be writing, for example, SQL create statements to do this. That's a lot of columns. So I recommend that you don't do that by hand. Instead, that you write a program that will actually generate the SQL create statements. Okay, and feel free to use whatever programming language you want. Um, Most likely maybe something like Java, or preferably something like Python. That would be a lot easier to just do a quick and dirty. Let's just get this going. Okay. Now, the reason that I say that is let's look at this right here. Okay. Um, A upper, A lower, UA, A ref, and so on. Now look at this one. B upper, B lower, UB, and so on. You see a pattern, right? You know, it's clear that for different parameters like A and B, right, which are semi-major and semi-minor axes, there's a lot of the same kind of stuff. You have the value of A, then you have the upper estimated value of A, the lower of the estimate of a URL for the information, you know, where you can actually find out more about how this parameter was discovered, etc., etc. Right? There's just a lot of information, but you know, if I have like 10 attributes per measurement, then I'm going to have a lot of different attributes. Okay, so that's one thing that I want to say. You know, think about using um, your skills as a programmer to make your life easier. Okay. Now, something else that I want to say. This is already in a table format, right? I mean, it's a table. It's got rows and columns, but it's not a good table. It's not something that I will put in a database, precisely because it is not normalized. Okay. So part of your job is going to be to normalize this data. You will take this and split it into multiple tables. Okay. Now, that means you'll need to know the functional dependencies, right? And to do that, you'll actually need to understand a little bit about this data. So part of what I gave you is a paper, right, that actually describes this data. It's a technical paper. You may be able to read this paper and understand it fully. You may be able to just read it and kind of grasp some of the details. I particularly encourage you to look at Table 1. That will tell you a lot, okay? And I want to emphasize this. You don't have to know a lot about astronomy to do this project, okay? It'll help if you know the difference between, for example, a moon and a planet and a star. Okay, yeah, galaxy. Right. I mean, these are just basic facts. There's nothing deep that you need to know. For example, you need to know absolutely nothing about the methods that are used to discover exoplanets. So you'll see things there like radial velocity. You'll see things there like but for example, there might be a transit times. Okay, there's several different techniques. Don't worry about it, right? They're just names as far as you're concerned. This is called radial velocity. Who cares what that means? You just need to know that it's a name, and that's all. Okay, so don't panic about that. Okay, you know, you don't have to take a quick astronomy course to be able to do this project at all. Okay, all right. So that's your first job. You're going to take this data. You're going to create an ER diagram for this. You're going to build some SQL statements. You're going to run some queries just to make sure that your database is working, right? And you're going to zip it up and submit it. That's part of project 1. Okay. Now let's talk a little bit about project number 2. And with project number 2, what we're going to do is we're actually going to create a report using this data. Okay. Now, what the report is going to do is it's going to tell us in this year, let's say 2010, so many planets were discovered using this method, so many using that method, and so on. Okay. There's not very many methods, right? They're listed there in the data, so I think we'll be fine. But anyway, let me show you the project here. This is the output that you're supposed to generate. Okay, so you will generate a file that has precisely this heading. It's a comma separated value file. Okay, so the first one is the date. Maybe I should have called that year, because it really is just year. And then it will say, oh, these are the different methods: imaging, microlensing, RV, that's radial velocity, timing, transit timing variations. Okay, like I said, you don't need to know what any of these are, just labels. That comes from the data. And then you have another row that says, oh, well, this was 1988, okay? And we got 0, 0. Oh, we discovered 3 of them using the third one, which is radial velocity, 0, 0, 0, and so on. On 92, there were 6, and it looks like timing was the way that those 6 were found. Some years you'll find some done by one method and some done with another method, right? So you'll see different rows. That's the output that you will generate, okay? So that's it, okay? Now, we also have this file that I gave you, exoplanets.html, okay? And let me see. I'm downloading it to my computer. Let me go ahead and open it. And what you're going to see is just simply, it's just a text area where you could type, right? Right, there we go. Now, I don't actually want you to type. What I want you to do is to copy and paste the data, or rather the output from that program that you wrote earlier, which is the one that's supposed to generate this CSV file. And then you hit submit, and what that will do is it will generate a graph right here. And this is just data visualization, right? So, so this is a program that I'm already giving you. I'm giving you this web page, right? You don't have to do any visualization at all. You just do the database part. But I'm showing you how the data from the database might actually be used to generate, say, a graph for a web page or for a journal article or something like that. Here is the kind of information that you might want to get out of a project, right? So that's what you'll do, and you'll generate a lot more lines, right? And when you hit submit, you'll get a beautiful graph. Take a screenshot of that. That's part of what you will be sending me for grading. Okay, so that's project 2. Now, finally, let me show you project 3. And to do that, I'm actually, this is actually a web application, okay? And I'm running it in Eclipse because I'm not going to say that I like the Eclipse environment, but I think it's better than nothing. So I actually use Eclipse. And one of the things that I like about it is that if you put to-dos comments in your code, then it actually tells you, oh, here are some of the to-dos left. So you can click on this, right? And that takes me to a part of the code. This is what you're going to change. So right here, this is how you connect to the database. This is information for my database. Okay, this is how you connect to my database. But of course, you won't be able to. You'll have to change this so that it connects to yours. And then you might want to go here. And there's a comment that tells you what to do. It says, oh, this function should return an instance of the planet class. You can tell that because that's the return type, right? Planet. And it has to give a name. So string is some kind, name is some kind of a string, I should say. And we actually have to create an instance of the planet class that has the information about that planet. You get the information by going out to the database, and then you'll somehow build this planet. I mean, it's just Java code, right? New planet with these parameters, and return that. So that's to-do number 2, 15 points. To-do number 3 is with stars, and so on, right? So these are all just to-do items. And when you have them done, then that will actually finish the implementation of a web application, okay? So let me show you what I mean by that. I'm going to right-click on this, and I will say run it as Maven build, okay? And that's because this is a Maven project, and I'll talk a little bit about that in a second. But right now, when you run it as a Maven build, then this will start executing, and you see right here it's executing. You just finished compiling. There we go. Now it's running it, okay? And So now that it's running, you can bring up a web browser and simply point to HTTP localhost 8080, okay, and that brings up a search form, right? So for example, I'm interested in finding planets that were discovered using imaging. So I'll select that, I'll hit search, okay? And here are all the planets that have been discovered using imaging. Imaging's not very interesting. Let's try transit. Okay, oh, that'll be too many. Let's just try microlensing, okay? So hit search, and here are all the planets discovered using microlensing, okay? Now, the other thing that's interesting here is you can look, for example, at mass of the planet. It goes from 0 to 22.6261, right? And that is in Jupiter masses, okay? So these numbers here tell you what the smallest and largest, the min and the max values are for that particular parameter, which is, you know, mass in terms of Jupiter masses. So if I want to find a planet that is between, say, 2 and 5 Jupiter masses, I would say that. Okay, I want to find planets there, hit search, and here they are. You know, here's this was 2.6, 3.8, and so on. Okay. Now, the point, of course, is, well, how does it know that the smallest value is minus 84 and the largest one is 85? And I should point out that it's really useful to know that, because otherwise we'd just be randomly typing here. Should this be minus 50? I don't know what the value should be. Is there anything minus 15 and 0? Search. Nope. Let's see. Let's try minus 10. Right? Nope. Still nothing. But by having that information, then you can actually say, oh, these are the correct, you know, appropriate values for a search. How do we find those? We find those through a database, right? I mean, the database actually has the data. And one of the things I ask you to do is to, one of those to-do items actually goes to the database and returns this information. So it says, hey, these are all the things I found in the database for discovery methods. This is the range of values that I found for, say, mass of the host star from 0 to 3.3656 or, yeah, 66. Okay, so that's the information. Okay, so you know, that's how we do this. All right. Now, the other thing that happens here is, if you look at this table, it has information about the planet and also about the star. So let's hit the star, and this tells us, for example, oh, here's another name for it. All sorts of information that's in the data, right? Again, there's a to-do item that you will do to collect this. Then here's one that you can find planets, okay? And so this is information about the planet, the name of it, the star, the method of discovery, all that kind of stuff, okay? Let's find another thing. This one actually has 2 planets, okay? So that's how this application works, okay? That's what I want you to build, and that's what I'll have. Okay, now one last thing is I show you how to bring this up from the command line, rather from Eclipse. If you don't want to use Eclipse, you don't have to, okay? This is the exact same data, okay? And let me get to the right place, sorry, databases. Bases, ugrad. Okay, here we are. So right here is the root directory of the project. And like I said, this is done with Maven. So you can install Maven on your computer. And once you have it, you can do things like Maven Compile, for example. And that will actually, well, it will compile this code. Okay, there it is. I can clean it, right? That deletes everything except the source files. Okay, I can now compile it again if I want. Okay, that builds the system, but not. Oh, and I guess I should say I could edit the sources. Let's do. Right. So I can go here and actually edit the code if I want to. This is outside of an IDE, so you could be using Notepad++, for example, if you wish. Okay, and when you're ready to execute it, you can say maven exec:\java. Okay, and give it a second, and boom, there it comes. Okay, so you don't actually have to use Eclipse. I recommend it, but you're welcome to use other tools that you're more comfortable with. Okay. All right, that's it. Good luck. If you have any questions about the project, please feel free to ask me. You can ask me during class and say, hey, I'm unsure about this. That's fine. We'll definitely try to help you out. All right. Good luck.